Hello, Maurits here, and welcome to this video about binomial distribution. We should look at a bit bigger question, and this could be a typical paper 2 question on an IB exam, so you expect to have the calculator available. Say the text says that a shop sells candy in boxes of 10 sweets. There are 10 kinds of candy, the red sort and the blue sort, and your favorite is the red sort, and the probability that a candy is red is 40%. We can from this see that this is binomial distribution. We have two outcomes, red or blue. It's 10 trials, so to speak, 10 sweets in one box, and the probability is always the same, 40% to get a success. So success is to get a red and fail is to get a blue. So in other words, we can say that the probability to get a success is the same as the probability to get a red, and that is 40%. We can write that as 0.4 or 4/10 or 2/5. And we usually denote the probability to get a success with the P. So the probability to get a failure, that is the probability to get a blue, is 1 minus the probability to get a red, since the total probability should be 1, and so that should be 0.6, and we usually denote that with a Q. So for this particular binomial distribution, the random variable x is the number of red candies in a box of 10 sweets. So x could also be said to belong to the binomial distribution with 10 as the number of trials, and the probability to get a success is 0.4, which can be written in this way that we have written down here. So what kind of questions could we typically get on this? So you buy one box, and the question could be find the probability that all are red. In this case, we don't even need to consider the thing about binomial distribution, just that we get a red and a red and a red and so on 10 times in a row. And so we can say the probability that our random variable x equals to 10 is the probability that all 10 of them would be red, and for each of them, one of them, the probability for it to be red is 0.4, 40%. So in other words, since it's a red and a red and a red and so on, we will multiply the probabilities, so that will give us 0.4 to the power of 10, and that will be a rather small number, as we will see. The 0.4 to the power of 10 would give us 1.05 times 10 to the power of minus 4, or in other words 0.00, so 123,105, or if we move the decimal point 2 steps, 0.0105%. Indeed, a very low probability. So certain enough, we will not get a success 10 times in a row. We can almost be sure of that. So let's go to the next question. So find the expected value of x. What would the average number of reds be if you would buy many boxes? And that we usually write as expected value of x, or we use the Greek letter mu for that. So the expected value, as I said before, it's a bad name. It should be called the expected average. Yet again, we don't need to think about this as a binomial distribution, just how many reds would you expect. And since we buy 10 candies in one box, and the probability to get a red is 0.4, our expected value of x is simply the number of trials times the probability that you get success. In this case, that would be 10 times 0.4, or simply 4. So we expect to get, on average, 4 red candies. If this expected value happened to be decimal number, write it down as a decimal number, because of course we could have a decimal average. So decimal number on your average. But in this case, it happened to be an integer. Next, we have a question here. Write down an expression for the probability that exactly 5 are red. In other words, we should write an expression for the probability that our random variable x is equal to 5. Pretend now that first we get 5 red and then we get 5 blue. Well, that would give us 0.4 to the power 5 times 0.6 also to the power 5. 5 successes first, 5 failures next. But this is not the only way you could have these 10 things mixed up in different ways. In other words, we want to figure out how many ways from the 10 could you choose 5 of them. So from 10 choose 5. That could also be, this part could also be written from 10 choose 5. Means the same thing. And since this should be a paper 2 question, so calculator allowed, we shouldn't even try to calculate this by hand, because the next question could be find the probability that exactly 5 are red. So now we should resort to our calculator. So if I happen to have one of these Casios, we go into menu, we go into stat, we go to distributions. This is a binomial distribution. We should look at the first one. The thing about this first one is to calculate the probability distribution, and the second one is the cumulative distribution. So this one is for a single value. So we'll go in here. I will change this to var, and x is the number of successes, that would be 5. Number of trials, that is the number of candies, that would be 10. The probability to get a success, that was 0.4. And let's calculate this. And we find that the probability that x is 5, in other words, we get 5 reds, is 0.2000 or 201 if we round to 3 significant figures. Say you are unhappy if 3 or less are red, find the probability for that. So in other words, we should find this, the probability that x is less than or equal to 3. So yet again, we can just resort to our calculator, but now we need the cumulative. So we press exit here. I can press exit again, distributions, but now the binomial and cumulative. The cumulative calculates the probability up to a certain number. So yet again, we go down here. We have already the 5 and 10, but with this we need to now change to 3. And this will calculate the probability that we get from 0 to 3. So in other words, this calculates the probability that x is 0 plus the probability that x is 1 and x is 2 and x is 3. So we can just press exit here, and we see that that will end up being 0.382 or 38.2%. So say that you're happy if 5 or more are red, find the probability for that. So now we should look for the probability that x is larger or equal to 5. But our calculator calculates up to a probability, so we should, in other words, calculate 1 minus the probability that x is less than or equal to 4, right? Because if it's not larger or equal to 5, it must be less or equal to 4. So we'll go in here again, exit. We can just change here this to 4, exit, exit, and we find this probability here. So we need to calculate 1 minus this 0.633. So we can go to here, 1 minus 0.633 or 36.7%. So suddenly enough, the probability is slightly higher that we get unhappy than happy in this case. Okay, how can we extend this question? Say we do like this. We create a new random variable here. So say we buy 6 boxes and let x, the random variable x, be the number of happy events. In other words, each happy event is that we have got 5 or more red in our box. And we should find the probability that the number of happy events is larger than or equal to 4. So in other words, our goal is to find the probability that h is larger or equal to 4. And yet again, we have a binomial distribution, right? Because either we get an happy event or not a happy event, and we have a certain probability for the happy event that we calculated earlier on. So we also see that we should calculate the number of happy events, that they should be larger or equal to 4. In other words, that would be 1 minus the probability that the number of happy events is less than or equal to 3. So the probability to get the success here, in other words, to be happy, is equal to the thing we calculated before. So we could here go in, and now we can see that we have one little problem. I don't know if 3 significant figures okay for this. So I would probably store more than 3 or keep more than 3. So we can actually go in here, menu, stat, and distribution, binomial. We have the cumulative, and we calculate this thing again, and we write down that with a little bit more digits. So that would be 0.63310,325. Okay, so then we calculate our probability here. So exit, go to this run mode here, and we calculate 1 minus this number. And since we can store this value, strangely enough, we can store this value and use it in our calculations later on here, but not the other way around from the statistics calculation to this. But I store this, so store alpha A. So now I have that probability stored. Then I go to stat, distribution, binomial, cumulative, and we should have 3 there, and we should have number of trials. We bought 6 boxes, and here I can press alpha A, exit, and then I got that probability here, x again to calculate, and we find that our probability to have less than or equal to 3 is this 0.8633, say. So then I go to menu, calculations, calculate 1 minus 0.86336, and that will give us a probability here of 0.137 or 13.7%, and we have solved this rather big question. And you can see that it was a 2-step question where we first calculated something using binomial distribution, and then we calculated a new thing using the result from the previous calculation. I would say if one manages this question, there's basically, that will cover a lot of the questions you can get on this. Hope this helps a bit. Thank you.